Hello everyone, happy to see you all again with a new topic called flip-flops. So what is a flip-flop, where it is applied? So applications of flip-flop will be, it is used in data storage devices, counters, registers and memory units. So counters where, for example, let us take a lace manufacturing company where it has to pack in a big box, like it has to put 50 packets inside that box. So there we need counters. So once it registers only, once it stores data only, it can add to it. So if it is not going to store the data, the addition will not happen there. So the mistakes can happen. So the data storage elements, counters, registers and memory units are the applications of flip-flops. So coming to flip-flop, a circuit that has two stable states is treated as a flip-flop. Flip-flops and latches are used as data storage elements. A flip-flop is a device which stores a single bit of data. One of it to two states represents as 1 and other state is represented as 0. Here in the flip-flop we have 4 types: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. We have 4 types of flip-flop: set, reset, toggle flip-flop. We call it as set, reset and toggle flip. So first we will go with SR flip-flop. So again flip-flop is designed with the help of logic gates. So that's what the main application of logic gates. Logic gates will be applied wherever addition has to happen or multiplication has to happen, or we have to invert some input and the output. So default it will be AND gate, OR gate and NOT gate. So coming to SR flip-flop. So flip-flop operates only there is a clock input, clock pulse. So the clock pulse will be the input for the flip-flop. And again the right side diagram shows the logic diagram of SR flip-flop. Here also we have 2 inputs, set S and R. So if we have 2 inputs, default we will be having 4 connections. So 0, 0, 0, 1, 1, 0 and 1, 1 will be the inputs. And coming, if S is 1 and clock pulse is high and R is 1, so 1 and 1 will be the output of OR gate, and again NAND gate, and again the bottom of the output will be NAND gate. The Q will be given to the will be given to the NAND gate, and this Q dash will be given to the NAND gate. So if it is S is applied as 0 and R is applied as 0, then the Q will be remains in the previous state. That is, there is no change in the output. So if it is 0 and 1, and the flip-flop will be reset, and if it is 1 and 0, the flip-flop will be in set condition, and if both the thing are 1, it is called as undefined solution or forbidden state. Coming to JK flip-flop, here also we will be having a set, reset and no change conditions. So the JK flip-flop is designed with the help of NAND gates. The clock pulse is very important for all the flip-flops. Coming to T flip-flop, this we call it as toggle. So input is 1, the only toggle and the clock pulse is given, whereas we have an output and an inverted output, that is Q and Q bar. So in the truth table we can see if it is 0 and the present state remains and the next state is also 0, the first condition. This it has only a single input. To avoid an intermediate state occurrence, this flip-flop is used to avoid an intermediate state occurrence. Sorry. So if toggle is 1, the present state from 1 is changed to 0 and the next state is changed to 1. So this is toggle flip-flop, and again this one is delay flip-flop. Either 0 or 1 will be the input, because since we have the NOT gate in the front, we can apply only 1, so either it will be 0 and it will be 1. So this is about flip-flops. So we have counters, right? So mod 12 counter needs how many flip-flops? So we need 4 flip-flops for mod 12 counter, since the equation is 2 power n minus 1. So by applying 2 power n minus 1, we get 12. So 2 power 4, 2 to the 4, 4 to the 8, it's a 16. 16 minus 1 will give you Thank you.